Hello and welcome to week 7. This week we are going to talk about two linear data structures, the stacks and queues. My name is Mildred. A stack is like you have data stacked upon themselves so that when you want to take out data, the last one in is always the first one out. And when you want to add data, you add it to the top. For a queue, you stack data so that the first one in is the first one out. So let's say a stack is like maybe you go to a restaurant and you have stacks of plates. The last plate that is put on top is the plate you take first, right? And for a queue, let's say you are waiting in line for a cashier at a supermarket. The first person on the queue is the first person that is attended to. And so that is exactly how it is in these data structures. There are several operations we perform on stack. When we pop, we remove the item from the top. When we pick, we look at and return the item at the top. We can check if the stack is empty, and then we can also do other operations that we want depending on our specification. We're going to look at how we implement stack in Python, but it's straightforward. It's just like the Python list. So we'll try to implement all we have said using a list data type. We can implement it just without object-oriented programming, or we can implement with object-oriented programming. So let's use object-oriented programming. Let's create a class called stack. Now, based on the definition, we have a list of items. So we'll say def init self. Now, this list of items are not like properties of this init method, but they are going to be something that will pass into this method. So we'll just have a first empty list that will store the items. So we'll say self.items is equal to an empty list. Now we can start creating methods that will push items, which is add item to the list, that will pop, that's remove item from the list, that will pick, that's look at the first item or the item at the top, and then we'll create a method that will check if the stack is empty. So let's say def push now self, and when we call this push method, we want to supply the items that we want to add to the list. Let's say we'll supply just the item, and then we want to say self dot, so we're going to append to this list items dot append, and then we want to pop, and when we pop, we are removing the item at the top. We want to check if this list is not empty, so we'll say if not self dot is empty. We're going to create a method called is empty shortly. So if not self dot is empty, we want to return self dot items dot. So this is a method in Python that we can use to remove the last or the item at the top of a list. Now let's create the pick before we create is empty. So we'll say def pick. So pick is what we use to look at the item at the top. So we'll say self, we want to return self dot items. So the item at the top is like the last item on the list, and so we use -1 to get the last item. And let's say if not self dot is empty, else none. So we just try to put this on one line. So we're saying if the list is not empty, return the item at the top, if not, return none. And then let's do the is empty method that we have been using. Now we want to have true or false, so we'll return the length. So let's say we return the length self items. So once the length of the items is equal to 0, to return true, right? And if not, to return false. We can also get the size of the stack. So we'll say def size, and this will give us the length of the item. So we can test this. So let's say the stack will be stored in a variable called s. We want to push, so s.push, let's push 10, s.push 20, s.push 30, s.push, and then we want to print the item at the top, s. Okay, let's see. So 40 is the last item, that's the item at the top, so we can see it here. And then we can also get the size of this, to say the size of the stack is s.size, and then we have the size is 4 because we added 4 items. We can pop and say s.pop, and to remove the item at the top, which is 40, and then when we want to look at the item at the top again, now it's going to be 30 because we removed the item at the top. So we see when we pop, we remove 40, and now the item at the top becomes 30. So this is the basic implementation of a stack. You can actually implement this stack using linked list also. I want you to try it yourself. You know the method we are supposed to create, so you try to use linked list to see how you can implement this stack. All right, so what are the applications of stack when we think about it? When we look at the different apps that we are using. For instance, you are typing in a text document or a word processing document. When you want to undo or redo something that can occur when the data structure is a stack data structure, where is the last thing that was done that is undone, or is the last thing that was done that you want to redo. We also can use it to backtrack, like in puzzles or games. We can use it to evaluate expressions and also for function calls. Let's now look at queues, which is the first in is the first out. We have two major operations that we do on queues. We enqueue, which is add item to the end, and we dequeue, which is remove item from the front. So we'll do that here. Let's implement a queue based on what we now know using the object-oriented programming. So we'll say class queue, and we want to create it similar to how we created the stack init, and we'll say self.items is empty list. Now we want to create a method to enqueue. When we say enqueue, we mean we are adding item to the end. Yeah? So def enqueue self item, and we want to add item to the end of the list, so we just use the append method. So self.items.append item def dequeue self, and what we want to do is remove the item in front of it. So we'll check if the item is empty, so we can create the isEmpty method first here, and we want to just check the length and compare if the length is equal to 0. So we'll say return len self.items equal to 0. So now we want to check if not self.isEmpty, we return self.items.pop, and we want to remove the first, so we'll always pop the item at index position 0. Right. So we can also create a method to look at the size. So let's say def size, and we want to just return the length of the items. Now we can test this. So let's say q is equal to q dot, we want to add items to the end, dot enqueue 10, q dot enqueue 20, q dot enqueue 30, and then let's print the q dot items. Let's dequeue q dot dequeue, print after dequeue q dot items. So let's test this. We run, and we have 10, 20, 30 added. When we remove item from the top, we have 20 and 30 left. Okay, so we can implement this using the collection modules dequeue. Like in Python, we have these collection modules. We can say, let's say from collections, we want to import dequeue, and you can read about the collections module and see all of the functions that you have access to that can make this faster. So we can use this to even make it faster, because when we use inbuilt modules or inbuilt functions, it makes our operation fast. So if you refer to your lesson resource, you'll see more examples of how you can do this without using object-oriented programming, how you can do this with the collections module also. Now, one application of queue is maybe you have the hospital system where people take numbers from a ticket to have the turn, and you want to do task scheduling, or you want to also have things that work with CPU processes or printer queues. Okay, we have different types of queues. We have the simple queue, which we have the basic first in first out structure, and it's just like the normal line you have at the shop. We have circular queue, where the last position connects to the first, and an example is like a circular buffer or like a rotating queue. And then we have like a priority queue, like the hospital example, where you'd use that in an emergency room where items are served by priority. All right, so we can dequeue when we insert and remove at both ends, like browser history navigation. So we can actually implement a circular queue, and if you look at the lesson resource, you will see example code of how we can implement a circular queue. All right, and so in summary, we have the order of a stack is last in first out. For a queue is first in first out. When we insert, we add at the top using the push operation for the stack, and we enqueue and we add at the top or the rear for the queue. For the remove operation, we pop and remove the item at the top or the last item, and we dequeue for the queue and we remove the item at the front. And when we want to access the stack, we can only access the top only, and for the queue front only. And the common use of stack is to undo and for maybe recursion, and for queue is like scheduling and buffering. So this is where we end this lesson. Thank you, and see you next week.